Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. You guys know one thing that is really nice about having monitoring set up in and around your home lab? The nice thing is, it allows you to wake up in the morning to 17 notifications telling you that your home lab is currently down and inaccessible. So that is what I woke up to one day this week. But the reason why it's nice is while it is a little annoying that it can, potentially blow your phone up, the nice thing is you can have down to the insert fidelity here to know exactly when something happens. So, for instance, in my case, I have a server running in the cloud that will periodically try to VPN tunnel into my home lab just to try to connect to it just to make sure that it's up. And if it's not up, it will then send me a notification letting me know that, hey, your home lab is not up. So this could be for a couple of reasons. It could be a power outage. It could be my VPN servers down. Or it could just be that my house currently does not have internet. But I have that set to run on every 15 minutes, so I found out that sometime between 1:30 in the morning and 1:45 in the morning, my internet connection decided it wanted to kick the bucket. So then I woke up, obviously, saw all those notifications, and the first thing I did was checked my VPN and my pfSense router. And the reason I did this is because I have been guilty in the past of assuming the reason I don't have internet is because of my ISP, when in reality my home lab just isn't functioning like it's supposed to, and that's causing me not to have internet. And sure enough, that was not the issue. Both of those were up and fine. And then I did the classic go-to solution on how to fix any problem, which is I turned off my ISP's router and turned it back on again by unplugging it and plugging it back in. And sure enough, my internet was restored and my phone stopped being blown up by my server in the cloud. So that was nice. But moral of the story here, I guess, is monitoring of your home lab and actually having it notify you of things like that is definitely something that's super important. And with that kind of little opening out of the way, let's get into this week's trivia question. This former titan of the internet and the tech industry was once valued at $222 billion, that's billion with a B, back in 1999 and held the number one spot as the most subscribed ISP with over double the second ranked ISP in market share with a 20% market share. What was this company? So some of you might know that one, but we'll see. So this episode, there's going to be some cybersecurity in it, and there's going to be a theme in regards to the cybersecurity aspects, which will segue nicely into this week's cybersecurity tip. This week's cybersecurity tip is kind of another core fundamental, I guess you could say, and that is cryptographically signing and verifying signatures to prove authenticity when doing basically anything. So if you're not familiar with how cryptographic signatures work, it's kind of a byproduct, I guess, if you will, of asymmetric key encryption or public key cryptography, however you want to refer to it. And basically the premise is you use your private key, which only you have, to cryptographically sign a hash of a a file, for instance, and then using the public key, you can then verify the cryptographic signature of the file or message or whatever to verify that those signatures match, and thus ensuring that the person actually sent the message to you who said they sent it, and it hasn't been tampered with in any way. So, and the reason this works is because theoretically, the person signing the message would be the only one with their private key. So this is kind of, how the general aspect of, the public key cryptography works is you sign the thing with your public key, or not your public key, you sign the thing with your private key, and then you encrypt with the person you're sending it to's public key, and then you send it to them. They decrypt the message with their private key, and then verify that it was sent by you with your public key. And there you go, encryption. So verifying that the signatures match is kind of like verifying the hash of a file, for instance, or a message, but the benefit here is you can verify the authenticity of not only the file, making sure that the hash is correct, but also verifying the person who created the file and created the hash of the file. So this can kind of be a benefit if you're potentially, say, trying to download a file from some website, for instance, and they have the signature, the cryptographic signature on the website, and you try to take the signature of the file, and those don't match, you probably have a problem. So definitely ensuring that you cryptographically sign and verify signatures is definitely something to improve the authenticity of the senders, and just in general to make sure that you're opening and reading things from verified people, and you're doing the same to others. So that is your cybersecurity tip for the week. And on the topic of cybersecurity, one thing that's kind of at the core of cybersecurity is when it comes to is privacy and managing of one's data. So I don't think it's any kind of secret that certain entities in the world like to harvest copious amounts of user data in order to sell to the highest bidder. And one really easy way where you can see this in action is if you deal with any kind of service that provides recommendations. Because in order to give good and accurate recommendations to you, they have to know what you're into, what you like, what you don't like. So your user data is very valuable to them. So I have made it a core principle of mine, I guess you could say, to notice and I guess for me, seeing that I am kind of more technologically aware of what's going on, I can kind of see this blatantly in action when an algorithm is, kicking into high gear to recommend stuff to me. So I will intentionally ignore every single recommendation that the algorithm is suggesting to me, even if I would want to, interact with that because it was a good recommendation. I will intentionally ignore all of them just to mess with their artificial intelligence algorithm to do recommendations and make it feel dumb, because it is. Because to me, at least, I don't think it can get any more blatantly obvious when, for example, I am, say, watching YouTube, and then I'll watch, say, a video on a topic or a subject that I generally don't, watch normally. And then when I go back to the home screen, over half of the recommended videos are related to that topic of that one video I just clicked on and watched. And I'm like, I see what you're doing here, YouTube. Not today. So, and it's the same thing on like, Amazon or any other marketplace where if you look at something or you buy something, you get flooded with recommendations for that thing. So another thing that I do also is when I see like recommendations for either products or whatever, if I see like it's sponsored, I ignore that because I'm not buying into that. Rewarding the person for paying to get sponsored. Or another thing I'll do too is whenever I see, say if I'm looking for, it's the holiday season, right? So say I'm looking for gifts and gift ideas, more often than not, most of the gift sites, or not gift sites, the sites that will like give recommendations for stuff will include like affiliate links, which if you're not familiar with what that is, it basically means if you buy something through the link that they provide, they get a little bit of money back from whatever the online retailer is. So what I'll tend to do is I will click the link to just kind of see, what the item is, and then either exit out and search for it myself, or I'll just go up into the URL and remove the sponsored affiliate link portion of the URL, hit enter, and go on my merry way. So yeah, but the thing is with all this, it sometimes it is kind of annoying, especially in the YouTube case where you just watch, say a video just because you were curious, and then you just get absolutely flooded with recommendations on things similar. So I like to intentionally ignore those recommendations and make YouTube's algorithm feel dumb. So that's just kind of something that the reason I'm bringing that up is it happened again this week, so I just thought I would bring it up. But also talking about things that happened this week, let's get into what nerdy stuff have I been up to this week. Now, I have to come clean to you guys and be honest with both you and myself because my counter has been reset back to 0. Yes, it has been 0 days since I have last recompiled the Linux kernel. I know I have a problem with that, recompiling the Linux kernel, and I will take the necessary precautions to ensure that, I don't relapse further. Joking aside, I did, finally get around to compiling the Linux kernel multiple times because, first off, why not? I thought it would be kind of fun too. And yeah, it was pretty fun. Also, if you are interested in compiling the Linux kernel, my recommendation would be either one, download the Git repository by just downloading it as like a zip file, or if you're cloning it, do not clone the whole thing. There are, I believe, over 1.2 million commits, so having to download all that history is going to take a while, so don't do that. There's a way that you can clone, just like, I think it's clone, if you do --depth equals 1, it'll basically do like a shallow clone and won't clone the entire commit history and make it a lot quicker. So that would be my recommendation. But yeah, it was fun to do. Now, if you want to talk about benchmarking like a computer, how fast it can compile the Linux kernel would probably be a pretty good benchmark, I would say. I guess the only potential snag you would run into is, depending on the operating system you're testing on, you may or may not be able to compile the Linux kernel, looking at Windows. But yeah, so that would be one thing that you would have to check. But I mean, on the other hand, you could always just throw a live USB, throw Linux on a live USB, boot into that, and then do the test that way. I guess on Mac OS, it would be a little bit harder, especially on Apple Silicon devices, seeing that their Linux support isn't it's kind of there, but still a little bit rough. But I'm sure if you're really dedicated, you could easily find a way to do it. But yeah. In other news, which kind of ties into what I wanted to talk about for the majority of this episode, was I created my own software license key generator and validator. And some of you are probably wondering why the heck I did that, or why I would want to do that. And I will get to that. But first, how I decided to model it was after the CD keys of the olden days, back when, you would buy a piece of software and it would come on like a CD, and then it would have like that 5-digit hyphenated, it would be like 5 segments of 5 alphanumeric characters on like the back of the CD case, that when you installed the software, it would prompt you to enter that license key. So I tried to model it after that. And one thing that I also did was I embedded information actually in the key, which, as we'll get into, is a pretty common practice when dealing with software license keys. But I managed to embed an expiration date into the key using base 36 numbers. And in English terms, that means I go 0 through 9 and then A through Z. So, you, like your standard hex values, you have your A through F, or 0 through 9 and then A through F. And then this basically just extends that through the rest of the alphabet. And using that, I was able to encode an expiration date. So if I wanted to be malicious, I could make it a subscription-based thing where you'd have to pay money every month to get a new license key, which personally I think would be kind of cruel, but everyone in the industry seems to be going that way, so I guess that would be the option, except the difference is, as we'll get into later, actually having a license key that you would have to re-enter every month versus having everything tied to an online account, for instance. So as far as the rest of the license key was concerned, I would embed the expiration date into like the first segment in base 36, as I said, and then the rest of the key would be just random hex numbers to meet the key length requirement, and then I would run a checksum on the entire key up to that point, and then append that at the end. And I decided to use the LUN algorithm. I think I'm saying that right. In other words, it's the algorithm that's used to calculate the check digit on a credit card. So I basically took that algorithm and then modified it a little bit to suit the use case a little bit better. And then I got even fancier, going back to the cybersecurity tip for the week, and I created an XML file system for the key. So the XML file would be the entire license, and inside the XML file you would have the key itself, and then you would have the signature of the key. So once I generated the key, I would take the cryptographic signature of it using my private key, and then put that in the license file. And then when it comes time to validate, it would first check to see if the key was even a valid key by checking to see if the date is past its expiration, and if the checksum was valid. And then if those things were both true, it would then check to see if the signature was legit, to make sure that the key hadn't been altered at all. And then if and only then would the actual license come up as being a valid license. So I don't really have a plan to use this. It was just kind of something, it's definitely been something that I've been thinking about for a while, partly because I've been debating whether or not I want to include this in my video game, but not for the reason you might think, because my plan with the game is for it to be completely free and open source, so you could download and play it and wouldn't have to pay for it at all if you didn't want to. But I I have been toying with the idea of potentially trying to add networking into the game and basically kind of allow you to trade and potentially do battles and stuff. Haven't fully decided if that's something I'm gonna do, but if it is something I'm gonna do, part of me had thought about potentially using the license purely as a means to use a server that I host, and that would essentially just try to offset the cost of hosting the server. And of course, with everything being open source, you would just be able to run your own server and not have to pay for anything. So literally, it would still be free. You would have all the functionality of the actual game itself, including all the networking aspects. It's just, if I did elect to go this route, you would just need a key in order to use a server that I would host, just to try to offset the cost of hosting the server, because I wouldn't be hosting it in my home lab. I mean, I potentially could, but that would be something I would probably just throw in the cloud. And if you put something in the cloud, hosting isn't free. So it would mainly just be to try to offset that. But at the same time, because everything's open source, you could always just sail the high seas and just get a valid key yourself without actually having to pay for anything. The only issue is because I decided to do signatures, cryptographic signatures, even if you did reverse engineer the algorithm to generate the keys, you'd still be out of luck because you wouldn't be able to generate a valid signature for it. But at the same time, because I have, valid signatures and I'm doing, public key encryption with that, what that would allow me to do is completely open source my script to generate the keys. And even with that, you still wouldn't be able to generate a legitimate key because you don't have my private key, which is the absolute beauty of cryptography, because good cryptography allows you to do exactly that. You can open source everything and it's still secure. So every, company out there that is doing privacy through obscurity should be taking notes, because if your cybersecurity is actually legitimately strong and valid and good, you can open source everything and it's not going to break the security of it. But that's just, kind of a little bit of an aside. Now, but going back, I guess, to kind of my thought process here, the thing of it was obviously having to, like I said, hosting isn't something that's free. But the other thing of it too is, if I open sourced the script to generate keys and everything, in theory that would also allow someone else to host their own server somewhere and use their own keys. So you would have to, pay them a license, which is kind of backwards, I guess, if seeing that they weren't actually the ones that created it. But if I didn't open source everything, and someone actually found a way to reverse engineer everything and whatnot, at that point I wouldn't even be mad because of all the work that you put into to doing it. But I have been kind of like I said, I've been debating if this is something I'm even going to do. But as far as the implementation goes, there's basically two ways I could implement it. The first would be technically less secure, and the second one would be more secure. The less secure option would be doing the key validation client side. And the reason why I say this is less secure is because someone could easily modify the source code to bypass all those license checks and then connect to the server. So that's obviously a lot less secure. Whereas if I did the license check on the server side, basically what I would do is when the client first connects to the server, they would have to send their license to the server, and then the server would check if the license is valid before allowing that connection or not. So there's trade-offs for each one. I think if I would actually implement it, I would probably do the latter. And then, of course, because everything would be open source, the actual option to do that check for, ensuring you have a valid license would be disabled by default, probably in some config file or something. And then, so that way, anyone that wants to host their own, they would be able to run the server and connect their game to it and wouldn't have to worry about any kind of licensing or whatnot. But that's kind of my thought process. Like I said, this is all still way up in the air. I haven't even wrote any code for anything networking related in regards to my video game. So still definitely up in the air, and kind of more of a thought at this stage, because there's a lot that goes into it, right? Like, I would basically have to come up with my own network protocol in regards to how, the client and the server are going to interact with one another. And I would want to have encryption, of course, because if this thing's going to be hosted in the cloud, I wouldn't want, that data traversing through the internet unencrypted. So that would be another thing I'd have to implement. So there's a lot that has to go into it. And obviously I would want to be a little bit further along with the game before I do that. So if I do actually end up implementing anything like networking related like that, it would probably be near the end of the development cycle when everything else is basically done. But we'll see. And with that, I think we can transition into license keys and how they work. So we've been talking about license keys with, me implementing a way to generate them and use them. But I kind of wanted to go into, what they are and how they work. So nowadays, with everything connected to the internet, license keys generally aren't as common nowadays. Now, you still have, your Windows license key to, have a valid copy of Windows. But even in today with license keys, I would say probably 99% of the time, your device is still connecting to a remote server somewhere to authenticate the key. So while, yes, you're locally entering the key, it is then reaching out to some server somewhere to basically do the authentication. And part of the reason this is done, kind of like I was alluding to when I was talking about my game, is the reason they do this is to basically make these keys one-time use. So in essence, you register, the application or whatever with the key, and then that will then phone home to whatever server of the company of the software and basically register that that key has been used to, your account or your instance or your device or whatever the case may be, and then render that key basically unused unless you unregister or revoke the key, then it would become usable again. So that's kind of in essence how it works nowadays. I was thinking for my implementation, not doing that. So in theory, if I created a valid key, someone could, just copy that key around and give it to everyone else, and people would have valid keys. But the reason why I don't necessarily want to go through the hassle of authenticating and basically making the key one-time use like that is then I would have to deal with, having some kind of database somewhere and maintaining essentially profiles of who the keys are registered, and I don't want to do that. That's, in my opinion, I guess you could say it's an invasion of privacy, but you could also argue it's not. But, I'm a very privacy-focused person, and I don't want my data being held by some company somewhere, by some person. So I'm trying to, extend, that same, I guess, decency, if you will, to others, and trying to be the change that I want to see in the industry and not house and hog a bunch of user data. But anyway, that's neither here nor there. Getting back on topic here. So nowadays it's pretty much all handled through online subscriptions and user accounts and whatnot in order to manage your licenses. So generally, you're not manually entering license keys and the software itself doing a check to see if that license key is valid and then allowing you access to the software. More often than not, it's reaching out to a server somewhere to authenticate and validate. And basically check that your user account, for instance, actually has permission or the license in order to use the software. But back in the day, that wasn't necessarily the case in all cases. So you'd have to enter the key, that came with like the CD, for example, after you installed it in order to use it. It was the same thing with Windows. Windows used to kind of give you like a trial period where you didn't necessarily have to enter a license. But then, it would kind of disable everything and basically not necessarily turn your computer into a brick, but it would be a lot less usable if you didn't have a valid license key. Nowadays, you don't really even have to register Windows and everything is basically as usable as it was. You just kind of get a watermark at the bottom saying that it's not, registered with a valid key or whatever. But the reason why license keys can be so useful is you can embed all kinds of information into the key. For example, like in my case, you can embed, if there's an expiration date for the key, you can embed that in there. You can embed what kind of key it is. So in like going back to the case of Windows, is it a pro license? Is it an enterprise license? Is it an education license? So you can embed what kind of license the key is. You can also embed things like, like I said, how long it's valid for, what kind of features the key will give you access to. There's a lot of stuff that you can kind of embed in there, and you can either do that by encoding values, or you can set certain elements in the key to be certain numbers or letters, which basically mean different things. So there's a lot of stuff you can do as far as embedding information into those keys. And usually most of those keys will have some sort of checksumming function built into them too, so you can't just arbitrarily write a bunch of random numbers or whatnot or change something and have it still be a valid key. So more often than not, there's going to be a checksumming process. So if you do modify, that's why if you take a valid key and you change like one value on it, it's going to say it's invalid more often than not, because the checksum would fail. Or if you say change, say one of the characters in the key denotes which version of the software that you're getting access to, so whether it's Pro, Enterprise, or something else, and you change that to a value that isn't actually one of those things, that will also cause the key to come up invalid as well. So some other things that license keys can be used for. It can allow you to, first off, even use the software. So sometimes if you don't have a valid license key, you won't be able to use the software at all. Or sometimes you might be able to use like a tiny bit of it, like it'll be like a trial or like a demo that you'll be able to use, but that's the extent of it. Sometimes you'll be able to unlock special features. So like in the case of Windows, if you have, say, the home license, you don't have, BitLocker, which is like the way to encrypt your drive for Microsoft. But if you get the Pro license, you do get that feature along with other features too. But sometimes you having the license key will allow additional features to be unlocked. Sometimes you can enable, it will also unlock additional customization options. Sometimes it'll enable certain performance options as well. So sometimes, like, the base version of the software won't allow you to say, I don't know, like multi-thread, for instance, and it'll kind of make your performance not as nice to kind of entice you to buy, the license to get better performance. So sometimes that will be an option. Other times it will disable bandwidth limits or other restrictions. So one instance of this is there are some tools out there that'll allow you to download, say, YouTube videos, for example. And if you don't have the license at all, I think some of them will have a limit on how many videos you can download. Whereas if you buy the license, you'll be able to download unlimited numbers. Another common one is ads. So if you buy the license, you don't have to see ads. That's another one. So yeah, there's a lot of things that the keys can provide, but this is kind of where some people take issue with license keys, which is why license keys are bad, and they'll make the argument that license keys are bad because you're getting the software that has all these features, but you're not able to use them unless you pay more money, right? Just kind of like with cars nowadays, it seems like they include all the software features, but you have to pay a subscription or something, or those features are otherwise paywalled, unless you actually shell out the extra bucks in order to unlock them, even though those features already exist. But here is where I would kind of make a counter argument, kind of sort of playing devil's advocate here, because being software, it's different in the sense that you can create different software builds for the different versions of your software. So for instance, if you have, say, a standard edition, a pro edition, and an enterprise edition, you could have just one single binary that you unlock the different features with the certain license key, and that is one way to do it. The other way you could do it is you could have 3 different binaries for each of the different versions, and in that case, no, you're not, you don't have all those features, and that you're not getting access to because you didn't shell out the extra money for. So there are instances where you could legitimately not have features built into the software that you don't have access to because you didn't pay money for. But again, it goes back to how the organization is building their software. So now, granted, I can almost assure you that their source code there's a good chance that their source code is all one thing. So that in the actual source code of the program itself, there's a good chance that all those features are in the source code, but it just comes down to when they build the source code, the features get removed. And one way that you can do that is you can do if-def checks. So when it comes to compile time, what you can do is you can specify flags at compile time to say, hey, I'm building the home edition, or I am building the enterprise edition. And then based on those flags that you pass in, when the compiler will go to compile your code, if the enterprise flag is checked, then it will include all those enterprise features inside of the build and inside the binary. But if the enterprise flag isn't checked, it will exclude those completely and not even include them in the binary. And the way that you can check this is if you have the option to download the different versions of the software that, say, the company provides. You can check to see, 1, are the file sizes the same, and 2, you can run a cryptographic hash to the file to see if the hashes are the same. So if the hashes are different, obviously it's a completely different binary. If the file sizes are different, completely different binary. So in those cases, you could see, are they bundling all of those higher end features into every single build, and you're kind of getting shortchanged because you're not shelling out the extra cash, or are they only doing a build for the features that you have access to? So while yes, if it is the case where they're bundling in all the features and it's a case of, you not getting access to them because you didn't shell out the big bucks, then I am totally with you. It's kind of that argument of, you're getting all these features anyway, and I'm technically paying for them because it's included and I have them, but I just can't access them. And that honestly made me think of a fantastic meme, which is, the who would win meme. And it goes like, who would win? Your ability to use all the features of the software that the software provides versus a 1 or 0 checker. Because in the case where everything is bundled together, so you just have one build of the software and it has, say, all the enterprise features in there, but you only have, say, the pro license, literally the only thing stopping you from getting those features is an if statement that basically checks if your license is the pro license, or basically checking if you have the enterprise license, and if so, you get access to this stuff. So you're literally getting your butt whooped by a 1 or 0 checker, because that's all a Boolean value is, a 1 or a 0. So yeah. But yeah, like I said, it goes back to depending on how the software was built. So some instances, those extra features will be included in the build, and other times they won't. And then the license would, either give you access to those extra features, or it would allow you to just use the software in general, depending on how it was built. So another thing that software license keys will do is, sometimes they won't just be like, your CD key where it's just a key that you enter in. In some instances, you'll actually have, similar to how I built mine, which is you'll get like, say, an XML file or something that will be your license key, or just license in general, and that will list out, all the features that will be unlocked by, having this license key. And generally, one of the things that'll be in there is some sort of, cryptographic hash or something to prove the validity of the license. So one instance of this is the on Dell servers, the iDRAC enterprise license, which unlocks, certain features within iDRAC. That is like an XML file that has like all the features that are unlocked, and you can't just create one because you have to, I believe it's cryptographically signed. There's something in there with it being like signed and taking, hashes and all that stuff. So you can't just, because I tried one time to basically create my own from an already valid license and trying to modify it for another Dell server, and it did not work. And I think part of that is, it being taught, well, one, if it is, with it being cryptographically signed, for instance, if I change anything, that signature is going to be invalid, because the contents is different, which is going to create a different hash and therefore a different signature. But the other thing too is, I believe how Dell does their licensing for, say, iDRAC, for instance, is they tie it specifically to the service tag. I think it's called the service tag, basically to the hardware tag of the device itself. So you can't use that license for another device because it has a different service tag. So this would kind of be a similar thing of basically taking a unique identifier of your device's hardware and tying a license to that hardware. Which I think this is actually how Windows used to do it. Obviously nowadays you still can do it that way, but now Microsoft tries their darndest to make you get your license through like your Microsoft account or whatever. But in the olden days, at least, this is why if you would change too many components on your computer, your license would then become like invalid because too much changed, and basically tying the license key to the hardware, which would still allow for some changes, but like if you change, say, the graphics card, the CPU, and the RAM configuration, and maybe even the drives or whatever, you might run into an issue with the license key not coming up as valid anymore. So that's one thing that you would kind of have to check for. But the nice thing, or annoying thing, depending on how you want to look at it, with newer licensing, adding cryptographic signatures to them, is it makes it essentially impossible to create illegitimate license keys and basically create like a crack software to make crack keys for the piece of software, because the cryptographic signatures would never match if you don't have the private key that's used to generate those signatures. So this is kind of, the importance of cryptography, right? Having that private key essentially allows you to ensure that you're the only one that can create valid license keys. So you don't have to worry about potential cracks, people generating keys themselves. But again, that doesn't prevent piracy, in the sense that someone could always take your binary, reverse engineer it, modify the binary to dig through it and find the places in the code that check for the license key and just remove them or disable them or what have you, and essentially allow them to use the software without a license key. So it's not a way to prevent piracy, but it's a way to make it a lot harder for people to acquire keys illegitimately, if you will, or reverse engineer the key algorithm, for example. And the other way that you can easily do this, the reason it's so easy is because you have your key generating algorithm, right? You have your script or whatever the case is, and you have your private key that then gets imported to sign, whatever, to make, the cryptographic signature. And then in the source code itself, for instance, you can embed the public key, because one thing you'd have to be careful of is, while yes, not embedding the public key and, say, reading it in from a file makes the code a lot more reusable, it also makes it a lot easier to bypass your cryptographic signature check. Because if you're reading in the public key from a file, let's say, a would-be pirate could easily, if they were able to reverse engineer the key generating algorithm to generate the key, they could use their own private key to then sign the license and then use their own public key as the key that's being read in, and their license key would be validated. So that's one reason why you would potentially want to embed the public key inside the source code itself to then be built into the binary. And mind you, though, this does not, completely remove the possibility that someone would be able to bypass the license check, right? Someone could still, go into the binary and manually edit it to remove the public key or just remove the check entirely. But it's just kind of, the Swiss cheese approach, right? It just adds, another level to make it that much harder in order to bypass. But on the topic of bypassing license keys, well, actually, I guess one thing that we can do to take a step back, that's, I think, one reason why these algorithms are usually kept so hush-hush. For instance, like the checksumming. I mentioned checksumming being a key part in these algorithms, basically, so you can't just create a random string of numbers and it be a valid license key. In almost every instance of license keys that you can look back through history, there's almost always some sort of checksumming going on to ensure that the key is valid, even if they're not using some kind of cryptographic signatures. And this is partly why, they want to try to keep those algorithms under wraps, because if it gets out on how the checksum's calculated, then anyone can just go out and generate their own license keys, which brings us into reverse engineering, because any binary that does the key validating or key checking inside locally is subject to a reverse engineering attack where someone could drop the code into a disassembler and reverse engineer the algorithm or the process for generating a valid key. Now, again, if you're using cryptographic signatures on your keys, that makes things a lot harder because they would also need to gain access to your private key, assuming they wanted to actually use a legit key and not just bypass the check entirely. But because like I said, in order to make sure that the key is valid, assuming you're doing that check locally on, like, within the software itself and not sending it off to a remote server somewhere, the algorithm and the process for checking if the key is valid is inside the binary. So you have the source code for how the key is generated. So if you can then throw it into a disassembler and kind of parse through the gibberish, because even the best disassemblers don't necessarily do the best job at renaming variables, so there will be some work on your part to kind of try to decipher things. But all the source code is there. So this would essentially allow you to reverse engineer the key generation algorithm in order to make valid keys. So this is how all those keygen or cracking pieces of software from back in the day, basically how they worked. They would essentially take the binaries of, the game or the piece of software, whatever, disassemble them, figure out how the key generation algorithm worked, and then create a program to then create valid keys for that piece of software that you could then enter to, have a valid key. Now, this kind of gets into a very legal gray area, and I will preface all of this by saying I am not a lawyer, so this is not legal advice. But my understanding of the copyright law, which I will have an article linked below, which I kind of use to reference this, it's my understanding that if you're able to reverse engineer the algorithm to generate a license key for the software you want to use, that's perfectly legal and it doesn't count as piracy. So if you yourself reverse engineer the algorithm to generate a valid key and use said key to, validate the software without actually paying for the key, that is perfectly legal. Again, that's my non-lawyer opinion from the reading that I did, and that would not be piracy. Now, here's where it gets into the gray area, but that's of course anything. So even if it's, say, Windows, for instance, say you reverse engineered the algorithm to generate valid license keys for Windows. If you manage to do that and use those keys rather than paying Microsoft for a license key, that is completely legitimate. Again, my understanding, not a lawyer. Now, here's where kind of the gray area comes in, which is as far as distributing the means of that key generation. So again, it's my understanding that if you reverse engineer how to make the license keys, if you can make the argument that it's to improve interoperability, you could distribute the software to generate those keys and it be completely legal. Again, not a lawyer, but that is my understanding. So if you can make the argument that by you reverse engineering the license key for X piece of software makes it more interoperable, you could then distribute that to everyone, which potentially would be why, those keygen programs were able to kind of go about the internet kind of uncontested, I guess you could say, because they could be making the argument that it's for interoperability, and they reverse engineered it themselves. Now, if you stole the trade secrets of the company to create the algorithm to produce the keys, that's obviously completely different. But if you go through the process of, decompiling the binary, reverse engineering the algorithm and whatnot, my understanding is you're in the clear. Which, in fairness, if I were a company and I found out that someone took my piece of software, reverse engineered how the key generation works, and use the keys that they generated, I honestly probably wouldn't even be mad. I would be more mad at my team for, allowing that to happen rather than, some random Joe being able to reverse engineer it. And honestly, if someone did manage to completely reverse engineer it and make valid keys like that, I would probably be, I wouldn't even be mad. I'd be like, man, props to you. You deserve it, because the amount of work and effort you put into was probably a lot more intense than actually just shelling out however much money it would be to buy a legit key. So props to you. So that is kind of license keys. Definitely a controversial subject, but it is kind of cool when you actually take a step back and look at all the different components that go into them, from the cryptography, the checksumming, the signing of the key and the licenses and whatnot. There's a lot of components that go into it, which is pretty cool. And if you want to get into reverse engineering, I forget the exact site, but I know there's like a site out there that will basically make sample problems to allow you to kind of like reverse engineer license keys, which was pretty cool. I know Low Level Learning on YouTube made a video about it a while back. I forget exactly what it was, but you could check his channel out and view that to actually find the site. Which actually, now that I'm thinking about it, since I'm recording this podcast, I will now go find it and drop it in the show notes if you are interested. But yeah, if you want to get into reverse engineering, reverse engineering license keys could be kind of a cool thing to get into. But also, talking about things to get into, let's get back into this week's trivia question. So this week's trivia question is, this former titan of the internet and the tech industry was once valued at $222 billion back in 1999 and held the #1 spot as the most subscribed ISP, with over double the second-ranked ISP in market share, and held a 20% market share. What was this company? And here's a hint. This company played a vital role in getting Americans all across the country online. And if you said AOL or America Online, congratulations, you got this trivia question correct. If you were thinking Yahoo, you can get out. Jokes aside, back in the day, Yahoo and AOL were kind of rivals, and they kind of butted heads, and I guess an ironic twist, they kind of ended up merging, which is a little funny because, butting heads and whatnot. But anyway, that was the trivia question. If you enjoyed the episode, you know what to do. Share it around, subscribe to the podcast. And if you have any questions, feel free to shoot me an email at contact@darkassassinsinc.com. There, you can always click the link in the show notes below for that. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.